Good evening, everyone. We are delighted to welcome Dr. Amit Doegar, Associate Professor in the Department of Computer Science and Engineering at the National Institute of Technical Teachers Training and Research, NITTTR Chandigarh, as our expert speaker for today's engaging session on building AI-powered product without coding, no-code AI and AutoML tools. Dr. Doegar brings with him over 2 decades of rich experience in academia and industry, having previously worked in a software sector in Bangalore. Before transitioning to the teaching and research, he earned his PhD in image forensic from Punjab University, Chandigarh, and holds an ME in computer science and engineering from the same university, along with the BE with distinctions from Karnataka University, Dharwad. His research interests span machine learning, image processing, data analytics, and open source technologies. For prolific contributions to the field, Dr. Doegar has authored more than 60 publications in reputed international journals and conferences, and has guided over 70 master's students in diverse areas of computer science, a life member of Computer Society of India and ISTE. Dr. Doegar is known for making complex AI concepts accessible through practical and innovative teaching. His hands-on approach in today's sessions will empower participants to explore AI without coding barriers. Over to you, sir.
Thank you, sir. Thank you so much for your nice introduction. Now I'm sharing my presentations. Kindly confirm me once. Is this okay or shall I maximize the screen size?
Okay, sir. It's okay.
Okay. Thank you. Thank you so much. So good evening, participants. So today my agenda for today is no code tools. So here I will uh, teach you or demonstrate you two tools. One is a teachable machine and another is the orange tool. And for AutoML, I will demonstrate two libraries. There are many libraries are there. One is PyCaret and another is H2O based on Python. And here on your Google chat, your chat, I am pasting this link so that all of you can join the Google Classroom if you have not joined so far, and you can download the presentations later on and the code right now and data sets. So I'm pasting this code. So all of you can join this Google Classroom with your Gmail account. So now with these words, I'm going to start the presentation. Wherever there will be any interruption or any, you can interrupt me in between. So today's agenda is to how to build the AI powered application without coding. So we will use no code AI tool and AutoML tool. Now there might be question arise in your mind when I'm saying no code, then why I'm sharing some code. So those code is related with the PyCaret and H2O. So when we talk the no code tool, so these tools, they do, either they will generate the code for us, either they will generate the automatically generate the code for us, or visually with the help of simple drag and drop system, we can make the applications visually with the help of drag and drop. So I will demonstrate one by one both the tools. So now, what is the importance of these AI powered applications with no code? So with no code, you can do a lot of things. It puts the powerful technology within everyone's reach, and the AI market already hits 13.9 billion in 2023, and it is forecasted to grow by 102 billion by 2032. So what is the opportunities are there? Students can start their own startups. They can do their own projects also, and it will no code tools will empower the entrepreneurs. So what is no code AI? Let me use one more annotative tool here. So the no code tools are just like a visual tool with drag and drop. So just you will drag and drop the components and you need not do the coding. And secondly, it will generate the code automatically. So when we talk on the no code AI or visual tool, so there will be pre-trained models will be there, workflow automation and data connectors will be there. So with low cost, we can build the applications very fast. So there are many no code platforms are there like Microsoft Power Platform is there, Teachable Machine, K9, Orange. So today I will demonstrate only these two, Orange and Teachable Machine. So already these presentations are available in the Google Classroom. Anytime you can download and you can refer it. So for AI builder, AI model builders, we have Teachable Machine, we have from Microsoft, we have the Lobe tool for automation platforms, for data integration, chat bot platform, we have different no-code AI tools are available. So for like data integration, we have Google Sheet AI functions, Airtable AI block is there. For chatbot platform, we have the dialog flow by Google, Chat Fuel for Facebook and Instagram. And for automation, we have IFTTT and Zapier are there. So now whenever you have to build the AI based application or machine learning based application, so first you have to focus on the problem. What is the domain problem? What is the you have to identify the problem. Then you have to choose the right tools. Then you can select the platform matching the skill and needs, and then you will collect the data and do some pre-processing techniques. So you can do the cleaning, prepare your data. Is there any missing data? So because if there is any missing data and if we perform any statistics on that, so it will not give the proper results. So we have to choose the right data strategy. And if you're working with agriculture data or medical data, then different pre-processing techniques are required so that the tool that you are focusing must be generalized with more accuracy. And you can build and iterate on the your data set. So there are certain challenges are also there in real time. So you have to see about the data quality. Like in case of images, what is the resolution? So poor data leads to bad results. So data pre-processing is the utmost important step. Then there you have to avoid the biasness in the model. And also you need to follow the ethics. So like related to the privacy issue, transparency issue. So already suppose you are working with some medical data or on some financial data. So there uh, you have to take care of these privacy and transparency and the ethics for this. And continuously with the help of these tools, you can make the model train again and again. So it will learn. So for ethics, there is another technology by the federated learning. So you can explore that also. Federated learning is one of the technique through which we can achieve the privacy in AI-based applications. So now what is the future of no-code tool? So you can transform your ideas into reality with no code needed. So whatever your ideas here, you can uh, convert into the reality. Then greater accessibility is there. So intuitive interfaces are there, AI assisted building tools are available, a lot of models are there. So one of the you can see on the uh, model zoo, I will show you one of the repository model zoo, and secondly you can see on the Hugging Face. So a lot of advanced AI models are available. You simply download and uh, deploy on your real-time application, and it democratizes the innovation. So anyone create the AI solution without coding. So these are the future of no code AI tools. So let me show you about modelzoo.co, and another is about the Hugging Face. So I am pasting these code for your reference in your chat box. I hope now this is visible and available to all of you. So if you see, you can browse framework wise or categories, and you can see n number of models are available. So if you scroll down quickly, I'm scrolling down, you can see n number of models are available. So either you can search on the top, you can filter the models. Suppose you are looking for object detection, you can give here object detection. Suppose you are working with face detection, you can give the face detection. Or you are working with some other application, you can give the, or you can browse the frameworks. So these are the frameworks like TensorFlow, PyTorch, MXNet from Apache, JAX, Jenner, Keras. All these models are available. If you are comfortable with particular library, or you can just click here and you can download and you can get the codes over here. Secondly, you can see by categories. So like you might be working with computer vision, natural language processing, generative models, audio and speech, unsupervised learning, reinforcement learning. So we will see today supervised learning and unsupervised learning examples, and self-supervised health and bioscience. So suppose if you work with computer vision, so n number of applications are available here. So in this way, you can explore these models. Secondly, if you are working with like Hugging Face, so you have the data sets are available. You can see on the left side related to the modalities, related to audio, text, time series data, or you can see the models also. So again, here you can see, suppose your area of interest to image, text to text, or visual questioning answering, document questioning answering. So all these things you can explore, like in computer vision, and number of applications are available like NLP and or text to speech or vice versa, automatic speech recognition, or speech recognition from one language to another. All these things you can explore later on. So in this way, n number of models are available which you can explore. So advanced AI models are available. Then now I'm going to demonstrate you about the teachable machine. So for this, I have already uploaded the dataset, or you can download some dataset also. So once you join to the Google Classroom, you will see there is a link available, a dataset of objects, and already I have trained the model. So now here I am creating one folder, and I'm giving the name here EICT, and today's date 16th May model. So we are going to create one model without coding. So right now there is no uh, model is available here. So I will show you how to create this model. And these are the data set of, I have taken some examples here. I have taken some images of aeroplane, drone, animals, car, flower, tree, and one of unknown and test images. So if I show you, so you can see some aeroplanes are there, which I have downloaded from the Google Classroom, from the Google, and some drones are available here, where some images of animals, or you can have your own image, your own custom image. Some car we have taken, and these are the some flower data set. and these are the tree. And you need not to bother about the name of these. There could be any name, because in the during deployment we will give the labels. So that also we'll see how we are going to give the labels for this. And one unknown. Suppose I'm giving some other image which is different from the given classes. So we have to give some unknown also. So just to demonstrate you, I'm going to create another folder. Let's say missiles. So how to work with the custom, I'm giving the name here, and let's say the name is I'm giving here missiles. So you can see right now there is no image here. So simple, what we'll do, we'll go to the any search engine. So here I'm giving the name here Google, and I'm giving here missiles, and I'm clicking on the images, and here I'm giving the name here. Just I will click on the images. So once we click on the image, we will see the different missiles are available. So just to for demonstration purpose, I am just downloading randomly. So I'm saving here as in the same folder. I hope now all of you get the idea how to create the dataset. So here I'm giving just M1, any name you can give. So now, so if you want to make your model more robust, so you have to take care of the more images with different background, different orientations. That's why in deep learning we perform the augmentation. So just for demonstration purpose, I am downloading only 4 to 5. One more will download. Okay, let's say save image as. So just for demonstration purpose, I have downloaded 5 images. Now after that, so we will go to this portal Teachable machine. It's a web-based tool, and it will help us to create the machine learning models or AI-based model easy and accessible to everyone. So in this presentation, here we have taken one example of we want to find how ripe a banana is there. So for this, we have taken some images of the banana. You can take any fruit, change the color, size. So here in this example, or you can, as per your requirement, you can make the classes. So you can capture the images through webcam also, or if it's on your machine, you can upload also. So both options are there. Suppose you want to do uh, auto attendance system for your class, and you required, and in case if you required your own data set, you can capture through your webcam also, and it is very easy. So just click on the webcam, and as long as you will click, it will create the those many samples. So here we are providing the labels here: too early, ripe, too late, and no banana in the image. And then we will upload the samples, and we will click on the, if you're using the webcam, you can hold to record. And now here in this example, you can see the to test whether banana is ripe, unripe, or overripe. So we can give the label here, and we can give the sample here. So you can see there is a hand is also there, and the banana is also there. So you have to take care. You have to give the appropriate uh, samples and click on the train model. So what is the first step? Upload the sample with the labels and then click on the train model. That's all. And after that, once the model is ready, you can see the accuracy also here. These are the labels, and then you can export it. Now there could be some issue. Suppose in your test image, if you give two bananas like this, so what will happen? Anyone? Any participant? What is your opinion? If we give two inputs, what will the output? So here machine will get the confused. So to avoid that, we should train with the different background, different lighting, all those criteria we can take with different tool. Now I'm going to demonstrate first this tool, then we'll go for the orange tool. So any question query from any participant so far? Okay. So now for this, just I'm opening this and I'm sending this link also. So on your chat box, you can see the same link. You can also open with, it will not take much time. You will see this kind of interface, teachable machine dot with google.com. So this is the first step. Then after that, click on the get started. So like here, I'm opening get started here. So we can do here three kind of problems we can do, like recognition of audio. You can give some input to the audio and you can recognize. For example, for some birds, for crow, for peacock, for uh, different kind of birds or animals, if you give, it will be able to recognize. Similarly, you can do the for the pause project also. So for the time being, we are only concentrating on the image project. So I'm giving my images under this project, image project. So we can save also, and we can suppose you have trained your the images of your class with 20 students and 5 were absent. So you need not to retrain it again. So next time you open the existing project, what you have done, and then you can add those 5 objects or 5 students. So for that, here we have these options: open an existing project or open existing project from a file or from drive. So right now we are doing from the scratch, from the beginning. So simple. What will the first step? We will click here. So I'm going to click here, image project. So after clicking, you will see a new window will open. A new window will open, and for this, the input images requirement is 224 by 224. Now, whatever the images I have downloaded from the Google, so that may be different from 224 by 224. So we need not to worry about it. So if you want to upload 500 by 400 or with different dimensions, so automatically it will pre-process the images to this size. It will automatically resize to 224 by 225. Then we will export, and using these libraries we can deploy. So we can use either TensorFlow library, and if we want to deploy on IoT devices or mobile devices, we can use a light version, TF Lite. And if we want to deploy on web, we can use a JavaScript based TensorFlow.JavaScript. So these are the steps. So just I will click here, and now new window open. So up to here, I hope this is fine. In case if you have any still any doubt, question, query, you can raise the question in your chat box. So shall I continue? Okay. So now here I have two options, either to capture the image through webcam or upload from here. Similarly, we can have for another class. So now I'm uploading the images. So when I'm clicking here, so it's giving me option import the image from Google Drive or choose the images from your system. So I will click here. Now this is a folder which I have shown you, and under this I have a data set of objects like aeroplane. So I'm selecting Control A and say open. So now I have loaded around 20 images, and here I am giving the label aeroplane. Similarly for second, either you write label before uploading or after, it doesn't make any difference. So let's say next I'm doing for the car. So I'm now uploading the car sample. So here I have the cars. I'm uploading the cars. In the same way, you can give your own custom data set. Next, we'll go with the drone. So now I'm uploading here and giving the drone and giving the name here drone. So two more classes we will do. Let's say one with flower and another with the missiles. So we'll say add another class and I'm giving the name here flowers. I'm uploading here. So under the flower, I have this folder. Different type of flowers are there. I'm uploading this. And last class, now I'm going to add missile. So under this missile, we add only 5 images, very few. So now I have selected the missile. So it is showing 5 samples. And last class we'll do with the unknown. Unknown. And we will upload this. And already I have created one folder here, unknown. So these are the images which are different from the given labels. So I have uploaded here. So this is the first step. I hope it is clear. So second step is to click on the train model. And third, last step is export the model. So without any coding, we are able to customize in this way. And whatever the models available online on various benchmark websites, so they are trained with thousands, millions of images. And in our case, we have only few images. So in this way, you can customize your own model. Then click on the train model. So now as I clicked on the train model, below that there is also another option, advanced option. In this advanced options, you can select the batch size, how many epochs you want to give, and the learning rate, or you can go with the default one. Now, whenever you do any AI based application or deep learning based application, these two hyperparameters are very important. So what is model? Model consists of parameters. Let me write on the notepad. Now what is model? Well, when we are talking about the model, maybe a machine learning based or AI based or deep learning based. What is model? So it is just like a mathematical model, mathematical model which consists of some kind of logic or equations. And this model comprises of parameters, comprises of parameters. Now, what are these parameters? These parameters are the numbers, which are consisting of weights. So whatever I've shown you here, model zoo, Hugging Face. So basically, you are downloading their weights, Hugging Face or model zoo. So when you're downloading or deploying this, what you are doing, you're using there, it consists of weights and gradients. It's in numbers. So similarly, and these are in the format of various formats are there. One of the format is .h5. So when we download, the extension will be .h5. Like when we are working with the C programming, we have the extension .c. When we are working with Python, what are the various extension of the Python programming language? It is .py, .interactive Python notebook. If you are working with Jupyter Notebook or Google Colab, you can use that. Or if it's a compiled, if you don't want to share your code, you can compile it and share the compiled code. So .pyc. Similarly, here the various extensions are there. One of the extension is .h5 format. So H5 format. So now model is ready. Yeah, I was about to tell you about the batch size and epochs. Suppose we have a sample of 200 images, and one option is that we can give the entire 200 images to the model. In case if we have GPUs with large memory, then it's okay. Otherwise, it's a there will be memory constraints are there. Memory constraints are there. So we can relate this example with 200 students. They are visiting some lab. So at a time only 40 students can, it can accommodate only 40 students. It can accommodate. So 40 students can uh, go at one at once at one at once. Only 40 students can go. So now how many iterations are required so that all students can go 200 divided by 40? That is a 5. Similarly, here we give the batch size, and this batch size is in the format of 2 to raise power n. So if we give the batch size only 4 or 8, then what will happen? It for 4 it will take 50 iterations, and for 8 it will take 25 iterations, lot of time. So normally we take, depend on the samples, either 16, 32, 64 or 128. If you have thousands of images, we can give 64 or 128 images. So these batch size also affect the accuracy. And what is the epoch? When the entire students pass through the lab or entire images, when they pass through the model, that is known as one epoch. So that is known as one epoch. So entire 200 images pass through the model, pass through the model. That is known as one epoch. So in this example, you can see it is taken 50 epoch, and with certain other criteria are there, early stopping criteria and other etc. So if we have 50 images, 50 epochs, and let's say we have defined here batch size 40, just for illustration purpose. So there are 5 iterations, 200 divided by 40 into 50. So 250 iterations will be there. So during those who have worked with the model earlier, they can see these iterations. So we can change it also, or we can go with the default one. So by default, it is taking the learning rate, batch size, epochs, all these things you can change. Now model is trained. So now what is the here last step? So you can see these are our labels: aeroplane, cars, drone, flower, missiles, and now we have to export it. So this is the last step. This is the last step. So what is the first step? Upload the samples, click on the train, and last step is the export the model. So we can export the model. So here when we export, again we have 3 options. either using the .javascript or TensorFlow or TensorFlow Lite. So I'm going to use a TensorFlow. So just I've clicked here TensorFlow, and now you can see this is a code and download the model. So you need not to write anything, just copy this, copy this, and those who have already worked with any of the IDE of Python like Jupyter Notebook or some other or Google Colab, and those who have not worked, they can also just simple copy and paste it. So I would open here collab.research and then say new notebook. Click on the new notebook and simple paste this code. So I'm taking another cell and simple paste this code. That's all. So are you with me? Anyone has any doubt so far? Shall I repeat the steps?
Sir, it's clear. Thank you.
Okay. So shall I proceed?
Yes, sir.
Okay. Okay. Now here you can give the name of your own choice. So I am giving here uh, teachable machine demo. Now before proceeding, let me show you one concept here. So it will help all of you. There is a repository here, pypy.org, and it is expanding. So last month it was around 6 lakh something. Now it has reached to not 6 lakh but 69 lakh. You can see these many codes are available. So if you are working with the generative AI or blockchain, you can see a number of libraries are available. Or if you are working in the blockchain or some other emerging technology or typo mistake, blockchain. So here you can see a number of libraries are available. Now how to use these libraries? So just using the 3-line code, I'm going to show you one example of uh, generation of QR code. Nowadays, all of us, we are using the QR code. And let's say this is my message. This is my variable. It's a type of dynamic typing. I need not to define whether it's integer, string, or float automatically based on the value. We all are learning AI through EICT workshop. Just I want to convert this into QR code. So what I will do, simple, I will call this library import QR code. I will call this library. And after that, simple, I will say QR code dot make, and I will pass the message. It will show the QR code. And if I want to save this, so I can say here some variable name. I will put in a variable, and simple, I will say variable one dot save. And here I can give the name my QR dot any name, appropriate name you can give my QR code or my QR, and give the file name extensions. So during the file name extension, we have PNG, TIFF, JPG. Whenever you click any image through mobile, extension is there. So you can give, I'm giving PNG, TIFF, JPG, GIF. Many extensions are there. You can give accordingly. So is it clear? Font size is okay. So now I want to run it. So simple on the here cell, just click here and it will run message. If you print the message, it will show. Now here, if I say print message. So it will show here. This is the output here. You can see the output here. Now when I will run the QR code, it may generate the error, or now you can see here. No module name, QR codes. So what is the solution here? What is the solution? We need to install this library. So as I told you, from pypy.org, there are various libraries are there. So how to install? Simple, very easy. So we'll simple write pip install that particular library. So similarly, if you are working with generative AI, generative music, and the library name. So in our case, we will pass this pip install QR code. So we will write here. This only this much knowledge is required. So similarly, here we require TensorFlow library. So here we will say pip q install QR code. Now this is just like command, and this is our command prompt. Normally it is required to run here. Normally this command is supposed to run here pip install QR code. But now I'm not running on the command prompt. I am running on the browser. So there are magic symbols are there. So I need to use the explicitly exclamation sign. There are many more magic symbols are there. So just before that, I need to put the exclamation sign. You can see here, simple pip install QR code. Now it has installed, and simple, very simply, I will write here import QR code. Now no error came. Similarly, in your case, from GitHub or GitHub, if you get the code, or like here you can see there are 263 projects are available in Python programming. Let me show you here. You can explore it later on. So here there are so many projects are available like human detection, forest fire detection, Indian currency, whether it's fake or original, medical data, lung disease, K-fold, disease identification. If you click on any of the image, you will see the code is available. So if you click here on .py, so this is the code. So you sometime you require Flask library or different many libraries are there. So in the same way, you can install the particular library. So I pasted the code. So now we will see. We have now we are going to make the QR code. Now QR code is ready. Now I want to save it in a variable. You can save it in a variable, and then variable dot save my QR code dot png. Now how to download it? On the left side there is a one folder. Just click on that, and you can see my QR code dot png, and you can click here and you can download from here. So now I am downloading. It is downloaded. So now anyone would like to scan it? I am zooming it. You can open your mobile, you can scan, and you will see the same message. So in this way, that's why Python is very popular. English like statements are there and easy to work. So dear participants, any doubt, question, query so far? Now we will proceed further with our problem. So similarly here we required one library, TensorFlow. So can anyone tell me now how to install the TensorFlow? Simple pip install TensorFlow, and we required the version 2.12.0. So after the installation of this, you can also check the version. Before installation, by default, many packages are available. So if you want to see those, you can simple write pip list. When you say here pip list, you will see more than 500 libraries are already available in the environment. So in this way, you can see TensorFlow is already there. Still, I'm installing this. So just to show you, so we can say import TensorFlow, import TensorFlow, and we can print the version. Print TensorFlow dot version. So we can see here that is running, executing. So we can write here version with 2 underscore. So it is showing here 2.18. So if you work this code with 2.88, it may not work. So which library version we require? 2.12.0. So that's why we have specified here version equal to 2.12.0. So now we are going to install. It will take few minutes and it will be ready. So it's going to install all the dependent libraries. So it's collecting those libraries information, and it is installing all these libraries. So by the time it is installing, any doubt, question, query from any participant. So I'm writing the steps here. First, we have opened the Teachable machine. After that, we have uploaded the sample. Those are the samples are in the form of the images and the labels we have given. Then we have clicked the train and click on the export the model. Fourth, we need to install pip install TensorFlow 2.12.0, and now we will test it. Model is ready, so we'll now test the real-time images. So we need to upload and test. So these are the only 5 steps. Go to the Teachable machine. No need to do any coding. Upload your sample. So in my case, I have uploaded the samples of aeroplane, missiles, drone, car, and flower. Then we have trained and export the model. And after installing, now we are going to test the real-time images. So now it is ready. We will restart the environment. And again, we can check the version. Earlier it was 2.18. Now it should be 2.12. So now it is correct, 2.12. So now in this code, you can see this is the one file, this is another file, and this is the image. Only these 3 we have to upload, that's all. So automatically now it's doing the resizing using this image of ops library. Then it will do the normalization and do the prediction. So now we need to upload these 3 things: Keras model, labels, and the image path. So we can see here. So now I have clicked on the download. So download my model. So now it's converting, and it's depend on the amount of the sample. It will take few seconds or few minutes. Now you can see it is in the progress, and automatically it will be downloaded. Converting the model, and now it's ready to deploy. So now it has downloaded. So now I can show you now. I have created here one folder, trainable model. I have created here one folder by the name EICT and today's date model. So now I'm pasting this and doing the unzip. I am extracting here. Now you can see there are two things. One is a model, which is around 2400 KB. This is a model and it is in the format of .h5. It is nothing but consisting of the parameters, and the parameters are nothing but the numbers, which consist of weights and the gradients, and this is the label. So you can see these are the labels we have given here: aeroplane, cars, drone, flowers, missile, and unknown. So suppose we want to rename. So need not to again retrain the model. Simple, you can say Indian missile. You can rename here. You can say Indian drone, or in the same way, just that's all. So in the prediction, it will show accordingly. So now these are the labels, and these two files we need to upload. So now I'm going to show you how to upload. So there is a folder. Even through code also we can upload, but we will prefer without coding. So there is a folder on the left side. We will upload this. We will upload, and again there is an icon here through which we can upload. So I'm clicking here. So now under this I am uploading the. Now you can see it is a case sensitive. That means lower m is different from the upper m. And here it is written here capital M. So just I'm renaming it. So either we can make here capital M, or we can make the lower M here, so that it should match. It is a case sensitive. So now this is the one file which is available in the environment. This is the second file. Now we have to upload the test image. So for testing, I'm going to upload, let's say, we will take, let's say, our test images. So let's say I'm going to upload this drone. Let's say this is a drone I'm going to test with, and or we can test this also. This is another drone. So now we want to identify whether it's a helicopter, drone, or something else. So now I'm uploading here. So simple, we can upload data set of objects, and that there is a folder test images. So here I'm uploading drone 3. After that we will upload some animal, and we will upload car also. Let's say this car. So you can, with the help of control key, you can upload multiple files. So we can select this also. So I'm uploading 4 samples to test. So now here just I'm changing the image name. Simple, I'm giving it the image name is d3.jpg, and we can verify it also here on the left side. These are the names. So I have specified now D3, then we'll check for D7, C10, and A2. Similarly, you can test the efficiency of this at your end. And now just we have to run. So now we are running it. And at the bottom, we will get the output here. So now you can see Indian drone, and what is the confidence score? 99.89. Is it clear? So similarly here we can test with another drone, and the name was D7. So we can check here with the D7, and we can rerun it. No need not to again upload again and again. Just we have to change the images. So now we can see again Indian drone. So now we'll change the sample with the car. So I will say here C10, and we will run it again. Now we'll see again it is showing the cars. Now we will give the another sample which we are not trained. So that was animal, and the name was A2, A2.jpeg. So this thing also you have to take care. So if you see here carefully, there are four images. One was in the format, three were in the format of JPG, and one of the image was in the format of JPEG. So we can run it again. And now we can see the result. So now you can see it is showing unknown. So in the last way, now in the same way, we'll test one missile. So now I'm going to upload the missile. Only 5 we have downloaded. So let's say any image we can take. So let's say M3 we have uploaded here, and we are changing here M3 m3.jpg m3.jpg, and we will run it again, and let's see. Yeah, so you can see it has recognized the accuracy also. Indian missile with 99.54% confidence score. So up to here, any doubt, question, query? I hope now this teachable machine is clear to all of you. So shall we proceed now for orange tool? Okay. So now orange tool, this is a link. Meanwhile, you can download. Let me show you here. Open link in new tab. And if in case if you miss something, you can refer this presentation again, which is already shared in the Google Classroom. So this is a link here. So you can download. It will not take much time. It is a open source and freely available. This is the interface. You can click here. You can get the download here. You will get the talks also. So now I'm going to demonstrate this straight away. Let me complete the presentation here, and I'm closing here the extra windows. I'm closing now this environment, teachable machine. I'm leaving this orange data mining. Okay, let me open it again. Now go tools. So now up to here we have seen about the one of the machine. Now another is the orange tool. So what is the orange? What is the benefit of this orange? Easily you can develop the ML based application. You can do the data visualization, pre-processing, supervised. Under supervised we have the techniques. So there is an official website here, scikit-learn. Majority of the developers, whenever they work with the machine learning, they use this library, sklearn. So I am pasting this link on your chat box. Scikit-learn. So you can refer these also the later on. You will get the entire concept knowledge. So now when you click here, you can get the classification, regression, clustering. Under supervised, when the label data, we can go for classification. If the label data is numerical, or when we have to predict the value, we go for the regression. So suppose whether the person is diabetic, and if it's the target variable is categorical, we go for classification. So similarly, here we have dimensional reduction, pre-processing, model selection, and just to show you, if I click on classification, we have these many models. Now using orange, we can easily find out which model is suitable for my problem, whether support vector machine, k nearest neighbor, naive Bayes, decision tree, so many are there. And if you click on any of the model, you will get the description also, and you will get the code also. You can get the code also. Or if you want to get the direct code here, then there is a scikit-learn, sklearn, or the scikit-learn. So you can click on the repositories, and there also on the repositories, you will get the entire code of these related to classification, related to regression, and so on. So here these components are called widgets. So this is the interface. In this interface, here you can read the data, then you can select, and these are the steps. You can visualize, you can select the model, you can load the data set, and you can use this workflow. Let me open this orange. So already I have installed this orange. And when you have to work with the different data set, you can use a UCI data set also. And in case if you have downloaded it from the Google Classroom, so there are also ML dataset ML by the name. One folder is there, or datasets you can download. So I am sharing this link. UCI dataset. So you can see there is a flower dataset, which is a foremost significant and multi-class. There are 3 classes are there, which consists of 150 samples of 3 flowers, which was created in 1936. It is very popular iris dataset. Then related to heart disease, related to bank marketing, related to car evaluation, and in this way you can explore. Or using the data type, you can see related to sequential, what is your subject area, like engineering or computer science. You can click here, you can search optical recognition of handwritten digits, energy efficiency, banknote authentication. So in this way, you can human activity recognition using smartphone, air quality. So if I click on banknote authentication, you will see there are how many features are there? 4. And how many instances are there? 1372. So like these are the statistical features are there. And in this way, you can download the data set. So now here I have downloaded this data set. So if you open the second section, orange, so there are data sets ML is there. Already it is there. And in case if you are not downloaded so far, you can use directly this repository for experimental purpose. So here I am now showing you banknote authentication, and this is the file. So 0 means it may not be fake, 1 may be fake, like that. These are the statistical features. So you can see 1, 0, 1, and some nodes may not be able to predict. So they might have given some other number. So you will find these files. So I'm going to show you about the iris dataset that I'm going to demonstrate. One is of the iris dataset, and in this dataset, these are the features. If these are the sepal width, sepal length, petal width, so we can predict this is belong to flower setosa. Another class whether it's a versicolor, and the third class is virginica. These are the features. So another data set that I will show you about the diabetes. So here we have the glucose level, blood pressure, skin thickness, insulin, Diabetes pedigree function, it's based on the uh, genetically, and the range goes from up to 2, around 2, then age and the outcome, whether the person is uh, diabetic or non-diabetic. So using orange, we will explore these 2-3 data sets. So now I have opened the orange. So first step, we will say simple, just like in Word, PowerPoint, we say new. We will click here new, and now you can see here. And I have installed some more tools like related to bioinformatics, image analytics. So how I have installed survival analysis. So when you open this fresh one, you will not see these tools. So these are options are available here. If you click on option, click add-ons. You can see here there is a add-ons. And once you click on the add-ons, so you need not to give any command or anything. Now what you required related to associate, related to network, prototypes, survival analysis, world happiness, or you require related to geo. So if you click here geo, so it will add dealing with the geography and geolocations. So just you click here and say OK. And right now there is no tool by the name related to geo or geography or geolocation. So just you click OK, and within no time it will install. So by that time it is installing, it will not take much time. So I request all the participants go to orangedatamining.com and download and install it. It is very easy to work. So now in this way you can install the other options. So we will see how to visualize, how to create a support vector machine, decision tree, various models are there, how to work with those models. By the time it is installing, let me continue with the presentation. Okay, it's asking you need to restart. So I am just clicking OK, and just I have to launch it again. That is a restart. So just launch it again and say new. So now I'm closing this instance. Already it is open new. Now you can see on the left side, Geo toolbox is available. And under this, we can do different operations. Now, if you refer the presentation, you can see you can open the file. Under this file, you can attach your file which you are interested. Then click on the data table to see and see the whatever distribution is there. So you can refer this presentation. Let me show from here. So what is the first step? You need to go to the orangedatamining.com. These are the other options that you can skip if you are working with the Linux or some pip. You can skip directly. You can download and install. After that, you will see these toolboxes are there. Like under data, these options are available. Under transformations, these options are available. Under visualization, you can plot Violin plot, distribution, scatter plot, line plot, uh, Venn diagram, heat map to see the correlation. Then different models are available. Logistic regression, naive-bayes, ADA boost, how to save the model, how to load the model, support vector machine, neural network, k nearest neighbor. All these models are there, and how to see the performance. So we have performance matrices are there based on the confusion matrix. So those who are aware of the performance matrices, let's say this is a confusion matrix, and we want to predict whether person is diabetic or not. So how we can find out? So maybe person with the we will have the ground truth. So this is a ground truth. This is a I'm here writing here. This is a ground truth or the data in hand. This is our ground truth, and this is a predicted by the model, prediction by the model, by the machine learning or by AI model. This is a prediction. So what it's predicting, positive or negative. This is a prediction. So what is the prediction here? Positive in this direction, positive. This is a negative, negative. Now if we see here carefully, when the person is positive and prediction is positive, this is known as true positive. When a person is diabetic and our model is saying no, person is non-diabetic, it is known as false negative. When person is does not have negative but machine is telling diabetic, so it is known as false positive. Person does not have diabetic and our machine is also telling non-diabetic, so it is a true negative. So here you can see these are the errors. Type 1 error, type 2 error. So our main purpose is to minimize these. And this table is also known as confusion matrix or contingency matrices. So based on this, we can get the precision, we can get the recall, we can get the accuracy, we can get the F1 score. So we will see also right now how it is calculating precision, recall, accuracy. So accuracy is true positive plus true negative, ratio of true positive plus true negative divided by all the values. All means true positive plus false negative plus false positive plus true negative divided by all. So in short, I'm writing here. What is precision? The true positive predicted by the machine by total prediction. So what is the total prediction by the machine? The ratio of this true positive plus false positive. So if I give you some number, easily you can calculate using this mathematical formula. What is recall? The true positive predicted by the machine divided by the actual ground truth. So what is the actual ground truth? Actual ground truth is true positive plus false negative. And what is the F1 score? You can click the photo also, because once I click here, automatically it will calculate precision, recall, accuracy,
I think sir lost the signal. Wait for a minute.
Sorry, it was disconnected. So can anyone can tell me where at which point it was disconnected?
True positive, true negative, sir.
Okay. So shall I repeat that again or shall I proceed with the orange only?
Proceed with orange, sir.
Okay, sir. Now, okay, let me, I think I have to share my screen again. I'm sharing my screen. Can you see my screen now?
Yes, sir. Visible, sir.
So now after installing the orange, just you will launch the orange. And if you want to install any of the add-ons, you can click on the add-ons. So I hope, had you seen earlier, I've shown you about how to install Geo or any of these. Just you click on that and click OK, and these add-ons will be it will be available in your environment. So now there are three ways. Let me delete this. How to call the file. So one option is that you can double click on this. Second option is that you can drag and drop here. And third option is that you can do right click and you can click on the file. So now I will show you how to read. So you can select browse, and wherever your file is there, you can select that file. Like in my case, I'm going to use a flower iris dataset, and it supports all these files formats, whether your file format may be in CSV format, spreadsheet format, Excel spreadsheet format, or maybe in pickle format, or tab separated file, or maybe in basket file, or almost all kind of files it automatically detect. So here I have selected iris dataset. Now I want to rename it. So this is the first step, iris. Now I want to show you another dataset that is a diabetes. I I can double click here. I can select my diabetes, which is in the folder here, datasets, orange. When you open the orange, there is a folder here, datasets ML. You can select any of the dataset. Now I'm opening diabetes, and now it's in the format of .csv, comma separatable file. You can see easily you can find out there are 9 features, 9 classes features are there, and data has no target variable and 768 instances. Now it has not detected the target, and if you want to do the classification or uh, it will not work. So what you can do, you can go to that particular variable, because now you are aware this is your target, and you can select here. So you can select on that, you can change accordingly target, or whether it's a feature. So you can do manually and click on apply. Now after that, you can see now it's showing the uh, target which is a categorical value, and then you can close it. So now I want to show you, as I shown you earlier, the repository, UCI repository. So you can, if you go to UCI repository, there are a number of data sets are available. So like here related to cancer, related to uh, here drug induced prediction, and many more. So you can, if you want to see, you can click on view data sets. By categories also, you can see subject wise. So most of you are from computer science background or engineering, so you can select accordingly. Either you can click on engineering. You can see data sets are available related to landmines, traffic flow forecasting. And if you click on computer science, you can see human activity recognition using smartphone, air quality, optical recognition of handwritten, banknote authentication. So if I open this file, or and this is the simple text format. So simple, I can copy the link here and we can paste it here also. So through that also, in this way you can right click, copy the link, and once you copy the link, you can see this is the link here in the zip format. So just here I'm renaming it to currency, and when I'm double clicking here, now instead of giving the file from me, what I'm giving URL, and I have given here the zip file and reloading it. So we can see whether zip file okay. So zip file is not supported, so you have to do directly. You can give the some other name here. So suppose here I'm giving iris CSV just to show you on Kaggle dataset or GitHub. So directly also we can copy the link. So again, or let's say iris CSV, and I'm giving the some GitHub direct link I'm searching here. So okay, this is a CSV file. So in the same way, like here you can see this is some URL and this is a CSV file. So directly you can give the URL also. So in orange, you can give the here I'm replacing with the this file. So I'm removing this. So simple, we'll drag and drop, and now we can give here this file name. So okay, some minor issue is coming, but in this way you can give the URL also. So now further how to see the data. So you can see the data table. So you can just collect here and double click on the data table. You can see the entire content of the file using the data table. Similarly here I want to see related to diabetes. So you can rename also and you can select here. You can see the entire content. So you need not to learn any coding or programming. Directly you can see in this way. So now if you see here, so I hope at least you got the idea how to open any. Now you want to visualize. Simple, you can select any of the visualize. Like here, I want to show you what the distribution. What type of we can go to the visualize. We can see here we have the violin plot, we have the distributions, we have the bar plot, we have the scatter plot, different. We have the heat map also and many more. Simple, just you will click here and click here. So now you can see this is related to the x and y, the relationship between two variables, insulin and body mass index. You can give the color also, and you can see the violin plot also. So you can see the violin plot of, you can select the uh, variable like body mass index, and you can see the violin plot. You can see the distribution of the data also. So of insulin, what is the type of distribution is there. So you can get the idea like body mass index, latitude, type is pedigree function, latitude, age. So easily we can get the, and we can also control it further. And similarly, we can see the bar plot also. So later on, if you don't require anything, you can select and simple delete it. So in this way, now you want to see the iris with scatter plot. You can see the iris. There are three classes are there. So it is showing here Setosa, versicolor, and virginica. Then you can see, you can open, you can see the workflow file data table. You can see the distributions. You can see the scatter plot. You can see different data table. Now we are going to build the model. So like here, let me show you what the tree. So here I am taking the model tree. I have collected here tree. Okay, tree. We will connect with the tree. Now I want to see the tree. So with the tree, we can use a tree viewer. Now we can connect here and we can see petal length, petal width, petal length, versicolor, and this is ready. Now when we have to build the model, there is a one you can view in this way. There is a one important parameter, test and score. Test and score. When we click here, it will give the precision recall F1 score. So let me show you again confusion matrix because there was a disconnection during that time. So here, let me show you about the confusion matrix. So let's say we want to predict whether the person is diabetic or not. So this is my ground truth at the left side, and this is my prediction, positive and negative. So just to recap it, or in the this is a prediction by the model, negative, negative. Now when the person is ground truth is positive and the prediction is positive, this is known as true positive. When the ground truth is negative and the prediction is positive, this is known as false positive. When the ground truth is positive and the prediction is negative, this is known as false negative. When the prediction is negative and the actual ground truth is also negative, this is known as true negative. So we have, this is known as type 1 error, type 2 error. We have to minimize this. So how to find the accuracy? Accuracy is true positive plus true negative divided by all. That is true positive divided by true positive plus false negative plus false positive plus true negative. What is precision? The uh, true positive predicted by the model by the, here let me use red color, true positive divided by total prediction by the model. So total prediction is true positive plus false positive. What is recall? So the prediction by the model, that is a true positive divided by the total ground truth. So total ground truth is true positive plus false negative. And the harmonic mean of precision and recall is the F1 score. So now how to calculate all these? So in the slide also you can refer. We will use the test score. So here this is our data. This is our test score and this is our model. So for test score, we have to connect with both. So for test score, you always remember we have to connect with the file or data and the model. We have to connect with the model. And model must be connected with the file. So only then, so model will take the data from the file and this test and score required to be connected, not after this. So some people they get confused. They connect file, then they connect the tree, like here. So like you have the data, then you have the model, then you can get the test score. This is a general score, but in orange, test score, I am, this is not the approach, but in, what is the right approach? test score has to be connected with the data as well as the model. So flow should be in this way. Otherwise, it will not give the result. So data here and model here and model here in this way. And naturally, this has to be connected with the data. So this is the correct way. So now let me demonstrate you quickly. We will deploy logistic regression tree, support vector machine, and then we will save how to save the predictions, and that's all for the orange. And later on you can open certain templates also there. So when you go to the orange, there are these templates are there related to text mining, related to classification, related to clustering. These are the uh, workflows are there, how to do the cross validation, how to do the clustering, hierarchical clustering. So you can open here. So once you open, double click that, or you can import here, you will get the templates here. So later on you can refer these data sets, distance, hierarchical. Let me now show you the quickly the implementation of different models. So I have opened several windows just to show you about the templates. So now I'm closing. So when you work with the orange, don't open multiple files. So here, now again I'm restarting the orange. And then we will proceed to the last topic, AutoML. And you will surprise, just in 3 to 4 lines, we are able to see the results. So now here I am taking the data, here file, I am taking iris dataset, and we can see the dataset also. We can see distribution also. Now we will go for the model. So, and then we can see the confusion matrix, we can see the predictions, we can see the test and score. So now, as I told you, test score has to be connected with the test score. So directly if you connect, you will not see anything. There is no, only you will see model name here, AUC, CA, F1, precision recall, and MCC. Now there is another concept here. When you have the data, maybe of Excel file or maybe in the form of images, then after that you need to split into training and test data. So training data is useful for train the model. Training data is used in short I'm writing here, uh, for train the model. And test data or unseen data, it is also known as unseen data or unknown data. Unknown data is to check the accuracy of the model. Check the accuracy of the model. So there are, so here I am writing here, to split we have the various sampling techniques are there. Various sampling techniques are there to split the data into training and test. So one of these is a holdout method. Another is a k-fold. Another is one leave out. Now what is holdout? You are randomly giving 70% data to the training and the remaining unseen data 30% to the test data set. Or you can give 75-25 ratio, 80-20. Now how to choose? So suppose you have 100 samples, 1000 samples, 10,000 samples, or 1 lakh samples. So here you can give 70% to the training and remaining 30% to the test data, and you can see the accuracy. Similarly, for a, you can give 750, or that means 75% you can give to the training and 25% you can give to the test data. When you have 10,000, you can give 8,500 to the training data and remaining 50%. It depends on the amount of this also, and in 1 lakh you can give for this ratio also. And you have to see whether your classes are balanced or not, balanced or imbalanced. Now what does it mean? Suppose we are testing some test, and for that test we have two classes. So let's say normal, or some other class is disease. Let's say we have here sample of 100 patients, or people, 100 people sample is there, and we want to test diabetes. So let's say around 60 persons are normal and 40 have the diabetes. So then we can see almost balanced data set. And if we again for the 100 people, if we are testing for, let's say here we have done the diabetes, and if we are checking for the COVID, so let's say in this we have around 90% are normal and 10% the COVID. So it is a problem of imbalanced. So again, there are various techniques to how to handle with the this kind of problem. So we can go for the k-fold. How k-fold works? So let's say we have done the five-fold. So we will have the five-fold, 1, 2, 3, 4, 5, and first fold will be used for testing, and remaining 80% will be for training. So out of 100, five-fold means 20, 20, 20 each. Each comprises of 20, 20, 20. So in second iteration, this will be the test data, remaining will be the training data. Similarly, with the third iteration, fourth iteration. So we will get the 5 accuracies. We will get the 5 accuracy. So finally, we have to get the average. So we can, this is also good approach, k-fold. And what is one leave out? So again, we have 100 samples and 95% are healthy, and only 5% are have some disease. So in this case, whatever model we take, accuracy will be always above 90%, whether it may be wrong also. So same to the k-fold, what we do, we take 100 samples, so we take 100 fold. So one sample is for the test purpose and remaining 99 for the training purpose. In second iteration, this is for the test purpose, remaining 99 including this one for the uh, training training purpose. So we will get the around 100 iterations. So it is more time consuming. So depend on various factors, we have these approaches. So similarly here in the k-fold, when you click on the model, you have the cross validation technique, you have the random sampling, you can here or leave one out, or you can give a test on trained data or this thing. So you can select accordingly as per the requirement, you can customize it. So now we require the model. So just to show you, I'm taking logistic regression, naive Bayes, ADA boost, and with this we will uh, open neural network. So simple, what is the now how to do? Connect with the logistic regression, compare, connect with this, and we'll get the result. So we get the AUC, uh, accuracy, precision, recall, Matthew correlation coefficient of the logistic regression. Similarly, we can connect with the naive Bayes. We can connect here, and now we can get the result of 2 naive Bayes and this one. Similarly, here we can connect here, and we can get the accuracy of this. Now the question arises: there are so many uh, algorithms are there. Which algorithm will be better? So we can use the help of the AutoML. So AutoML will tell us. So how many now algorithms we have implemented? If you want, you can take the snap also. We left with 20 minutes. So we can implement logistic regression, naive-bayes data boost, and so on. And finally, we can see now the accuracy here. So we can see now the logistic regression, naive-bayes data boost, stochastic gradient descent neural networks. We got these many accuracies. We can check by precision. We can customize classification accuracy, based on Matthew correlation coefficient. In this way, we can compare the model. We can change the k-fold also. Now we can get the different accuracy. We can change the random sampling. So we get the different accuracy. We can give the training size. We have very less number, so we can give the training size maybe 75%. So we got the different accuracy. And we can try leave one out also. So it will take a lot of time. You can see here now test and score is calculating. You can see the progress. We can use any sampling techniques. So whenever you deploy uh, any machine, what are the hyperparameters? We will see using the now AutoML. AutoML will do for us. What are the hyperparameters to do? How much, which, uh, which parameter to be taken care? Now let me show if this site will open. Papers with code.com. Now I'm sure most of you might have used some deep learning. So once you click on the methods, you can see there are activation functions are there. So can you name me some few activation functions? Like you might have heard about the ReLU, this one, you can click by now year-wise. So in 1994, this was proposed. ReLU was proposed in 2000. And if you see in the chronological order, now in 2025, TAF, CAN, DRA, these methods have been proposed. So which activation method is good for us? So AutoML will tell us. So next topic we will talk on AutoML. So any question query so far? So now shall we jump to AutoML?
Excuse me, sir. So I have a question.
Yes.
Sir, what kind of pre-processing can we do here? Like, is there like what are the functionalities available? If you can we
Okay.
do some customized pre-processing?
Yes. In case if you have already done, you just click on the here transformation. Like here we can do like normalization we do. If just to show you, we can click here pre-processing. So we have these methods are there. If some method are missing, so you can impute how to use those. Sometimes we impute or replace with some other method. We can click select. We can normalize the feature, randomize the features. And if you want to learn more on these pre-processing technique, again I will recommend you go to the scikit-learn if you are working with the machine learning and click there on the pre-processing here techniques. Are you able to see?
Yes, sir. I can.
So here you can click here pre-processing. Again, you can do the standardization, mean removal, variance, and number of techniques are available. Scaling, and even if you are working with the you are interested in with the Excel file or some images.
No, tabular data would help, sir.
Excel file.
Yeah.
Okay. So another I will recommend you just go to kaggle.com and just simple write here pre-processing techniques. Pre-processing techniques. You will get the lot of data set, code, and various techniques. So comprehensive guide if you are working with imbalanced data handling, or you can see a number of options are available. So now let me show you about the AutoML. You will get the more idea.
Okay, sir. Sir, one more question, sir. How do we save the results?
Oh,
Like
sure.
the,
Yeah, I forgot to
the
say.
plots, the plots.
Yeah. Yes. So here you can see under model here, under model, there is a link here, save the model. So later on can you see?
Yes, sir.
Save model, load model. You just click here, connect it here, click here. Now you want to save in your local hard drive? Yes. So here on my machine, so I will save here under orange my whatever the appropriate name you want to give, my saved model. Is it clear?
Yes, sir.
So you can save in this format, my saved model, and now it has been saved. Later on I want to use it, maybe later on. So now I'm do you want to save this workflow? You can save also, just I'm discarding it. And later on when you open this orange, again when you open this orange and you just click here, load the model, and double click here, browse. So here in this folder under orange, I saved here only I saved. I think I saved in the, I think I have not saved the environment. That might be the reason. But let me show you simple here. Again, it will not take much time. So you take the file, and after file, you upload your data like iris. Then you click on the model. Let's say two models I want to use, database and support vector machine. Then you connect with the database support vector machine, and then you click on the evaluation test and score, and connect with the test and score, and after that click on the save model. So you can see here database support vector machine. Okay, some okay. So now this is my file, and now I'm selecting the model randomly. I'm selecting, let's say, KNN. And then I'm selecting the model here, KNN support vector machine. Here I'm selecting the evaluation test and score. So I need to connect with the in this way. So data is connected with this one. In this way we can connect, and now we can see this is a KNN score. Same with the other models. Now I want to save it, so I will click here, save model, which is available under here, under model, save model. So I'm saving here, SVM, save it here. And the next session that I'm going to show you now in the AutoML, that is more appropriate. You will get the better idea. And then later on, if you want to upload it you want to use it, you just try load model. In the presentation also, it is mentioned here. You can load the model, you can browse, which I have saved here, SVM PKLs, and now it has been loaded here in this model. Now it is available here, and then you can connect it with the test score. So let's say I'm taking evaluation again, uh, under evaluation, test and score. Now this is SVM, and this SVM need to be connected with the data. So you just refer the slide, and again in the Google Classroom I will upload this template. So it is easy here, nothing like that. A lot of options are there. If you want to be working with the unsupervised or this one also, you can select that. So let me now demonstrate you about the AutoML. So in AutoML we have many libraries. These are the pipeline. So these are the steps are there. First you need to call the library. Many libraries. I will just quickly demonstrate you about the two libraries. So what I will do now, I will simply, it is in my rep, in one of the file, I will simple copy paste and show you. So here now for AutoML, let's say I will install one of the library PyCaret. So you can also try, it will take hardly not much time. So, so I'm closing the other windows. Hello, hello. Are you able to see? Hello, hello.
Yes, sir, we
Yes, sir.
can.
Let me close the other windows. Okay. Okay, I will share. After this, I will share. You just run if those who are interested to see AutoML. This is a very promising area, a very powerful area. And let me open my file. I've opened so many windows. So just to show you what the AutoML. Within no time, it will tell us which method is better for us. I am closing the other windows. Yeah. So now you can see here. I have installed the pip install PyCaret. Pip install PyCaret. Only this is the one command which will take some time, and after that directly you can start working with this. So here I will share this file also later on. So AutoML, now we want to see the classification. So I'm just 4-line code. Let me paste in your chat box also. I will upload this file also. Just simple copy and paste this. So what it's going to do, if you see here in AutoML, so we have installed one library PyCaret. You can upload your file also, and we have import the data. What we are doing from, like when we do some trigonometry functions from math library, what we say, from math import trigonometry functions like tan, cosine, or we can say import everything. So what similarly from PyCaret we are importing one get data, and from PyCaret.classification we are importing all classifiers. And this is our data, maybe Boston dataset, diabetes dataset, iris dataset. This is a classifier. Just how we are training the classifier, we are saying here setup. Now it is ready, and it will say target, and we are saying the class variables. So in diabetes, if you see, if I show you the file, the variable is outcome. If you see here, diabetes dataset under, even you can get the under orange. there is a folder by the name dataset ML. If you download it, dataset, there is a diabetes, heart, breast cancer, iris. So if I open iris, so you can see these are the features, these are the uh, results accordingly. Similarly, when we open the diabetes, so these are the features, and the final outcome is in the this is the target variable. So just only this we need to define. So outcome, and we can compare the models, and then we can evaluate the model. Let me show you here. I have just copied this. I have pasted here. So from PyCaret, now it's going to run it. And after that, we can see which is the best model. So I'm closing the other windows. I think I closed wrong window. So now after that, we can simply say evaluate the model, which model is good for us. So it will not take much time. So you can see this is a diabetes and the column outcome not found in the data. So maybe case sensitive, or we will check here. We can say here, let's say target is like this only, because it's inbuilt. So we are saying in this way only. And evaluate model class variable. Now it's running. So internally it has taken the class variable. Otherwise, if it's your own file, accordingly, what is your target, you can select accordingly. So now it is going to run logistic regression. And can you see naive-Bayes classifier, k-nearest, decision nearest, support vector machine, and it's giving all the matrices, performance matrices, accuracy, recall, precision, F1 score, kappa, Matthew correlation coefficient, total time took by that particular algorithm. So still it is running. Support vector machine, dummy classifier. This is just like a base model. So all classifier performance must be higher than the dummy classifier. Then now we want to evaluate the model, which is best one. So we have the raw data. We can do the hyperparameter simple tune, and we can run this. So anyone is able to run this program. So now we want to do the regression. So now how to do the regression? Simple. So from pycaret.regression, import all the regression methods. So what are the regression methods are available? If you see here, scikit-learn.org. Can I take more 5 minutes? Under regression, you can see there
Yes,
is
sir.
a
You can take.
less so large, just participant last 5 minutes I will take. And if you can see, a lot of methods are there. Which one is better for your data? Because it's a data dependent. So here in the Google Colab, you can also try here regression, just 4-line code. This is a data set, and here now I'm going to run it. So now you can see this is a data set, and so internally it's doing, and now it started the regression, ridge regression, Bayesian regression, elastic net, lasso, k neighbors regression, orthogonal matching. So you can see a number of, and we have to see whether which parameter we are interested, either r square or RMSE or mean square error. So if you have little knowledge of pipeline of machine learning, so using the AutoML, easily you can find which method is better for your algorithm. So similarly here, you want to do clustering. So for that, we are going to use the jewelry dataset, and we can plot the model. So now in clustering again, if you open again scikit-learn, so many methods are available. So using the pycaret and data could not be read, and sometime when you do the copy paste from the Word file, you have to be careful about the this one. We'll see. Let's see if it works. Yeah. So there was a ASCII code difference sometimes comes. So now when we have deploy the jewelry, so you can see related to PCS plot you can do, and here with which method we have used the k-means. So like anomaly detection, you want to see any anomaly is there. So there is a forest algorithm is available. So now you can see here, you can deploy the anomaly and you can see in this way. So similarly, there is another powerful library H2O. And if you see the presentation here, which I skipped because of the time constraint, uh, so industry is also using this. In H2O, Google Cloud is there, Data Robot is there, and many more examples are also given here. So you can refer this, how it works. Now, how many models we want to compare? So we want to compare 10 models, 10 top models. We want to exclude these algorithms. Whether we want to use n-fold cross validation, we can see. So everything is mentioned here step by step. So kindly refer this also. And again, I will share the link also. So how to work with the now simple this one H2O. So here we have seen regression method, clustering method, classification method. In the same way, we can do with the H2O method. There is a concept of leaderboard. So simple install pip install
Rani de.
H2O, and then now this is my last code. I will upload this file. So in this way, you just upload and you can run the code. So you can import file locally also. You can upload file locally also, or in this way from the link also. So now I stop here, and again I'm sharing my link of Google Classroom. So now I stop here. Any doubt, question, query from any participant? Yeah, this is a Google Classroom code. So you can join here. So what we have done today, so we have learned two tools for no-code tool. That is a T1 teachable machine, another is a orange. So please explore as much as you can do. Then we have done two libraries. One is a PyCaret and H2O. So uh, I will upload this file also in the Google Classroom. Let me upload right now. So meanwhile, anyone has any question query? So now you can see H2 has been installed, and when you run this file, you will get the result. So here we are importing the H2O AutoML library, and how many models we are interested to see? Top 10 models. So let me share this file also. So under classwork, there is a folder presentation dataset code. So both presentations are there. Dataset of object orange, and now I'm uploading this material, this file. So just you can simple copy paste and run this. So with these words, thank you one and all. So I am uploading both two files. It's a
Sir,
simple two files.
few
Yes.
questions are there in the chat. Sir.
Okay, I will see. So now I'm saving it. Let me show you the result of this. Now when we run this file, so it is still in the progress and taking now 100. You can see XD boost, then stacked unassemble, and there log loss, RMSE and MSE error. So now let me see about the query. Yeah, what are the questions? Can we get this model in and as a research flow diagram? Can we get this model in and as a research flow diagram? Yes, we can see. Can we get this model? Are you talking about the orange? If you see about the orange, you can save your workflow also. Like here, these are the workflow, orange workflow. So like here, you want to do some cluster analysis in bioinformatics. So right click, open with your orange. You can open these, or if I open here these workflow, yes, you can save your workflow also. So like here, I will show you how to save your workflow. You can say open or open the this one open, and then let's say we were doing the related to bioinformatics clustering analysis. So you can open. Now this is a workflow. Then you want to do something here. You can add something. You want to do some visualization. You want to do something, and you want to save it. So you can say file, save as. You can save the workflow image as SVG format also, or save as. And then you can save the workflow. So you just explore the menu. Okay. Any other question? I hope now this is clear. So there is a menu here, and you can save as in this one. So still later on, if you have any question query, you can post in the Google Classroom, and we will see and we'll try to reply. Okay, there is another question. Will Tinker GUI package working in Google Colab? Okay, right now I am not in position to give the answer. I will test it and give you the answer. So if you are joined the Google Classroom, or you can have my email also, or if you are part of the Google Classroom, automatically you will get. So I am saving your question. I will first I will explore it, and then I will give the answer there. So now here I am saving here under this class notes and queries. Okay, can such topics be included for students teaching in syllabus? Yes. Can such topics be included? Yes, yes. Why not? So now even Intel has started training manpower, uh, future workforce, and in future workforce they are including this no-code tool. They are emphasizing on Orange. They are even many tools, Orange and this H2O library. Yes, many nowadays people are any tool for get to draw the neural network architecture. Yes, there is a tool. Even one of our research fellow, he has used that tool to draw the neural network architecture. So I will kindly join to that. I will show you. Normally, okay, this like in this way you can save your workflow. What I have shown you, you can give the name workflow, and later on you can open this. So I am saving this question also, and there is also one another very good tool by the name draw.io. Draw.io. Here, if you see draw.io, you can download it also, or on the cloud also you can make the flow chart. But for neural network, there is another tool. Right now, I'm not recalling, but tool is there. So again, I'm in the black mode, but you can make the some algorithm related to arrow flow charts, some ER diagram flow chart, or more shapes, UML, and even in PowerPoint, you can make use. So in this way you can give the color draw.io, and even in chat GPT there is a one tool by the name Mermaid. So I don't think we have much time. So you can try on chat GPT Mermaid. Just you write Mermaid, and through that also you can customize to a lot of this thing. So I have taken your much time. So still, if you have any question query, please keep in touch, and you can feel free to ask the question anytime. So any other question query from any participant?